Hi everyone, welcome back to my YouTube channel. So today we are going to solve day 15 problem of this month on LeetCode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. Problem number 2429. Minimize XOR. Okay, let's read the problem statement first. We have given two positive integers num1 and num2. Okay, we have to find the positive integer x such that x has the same number of set bits as num2. Okay, same number of set bits as num2, and the value of x XOR with num1. Okay, it should be minimal. All right, note that XOR is the bitwise XOR operation. We have to return integer x. The test cases are generated such that x is uniquely determined. The number of set bits of an integer is the number of ones in its binary representation. Okay, that's the definition of the set bits. All right, so now let's understand this with an example here. So see, this is my num1. Okay, and how I'm going to represent num1 in binary form. So here I can write it like this, right? 0 1 and 1. Okay, so this bit value is 1, this bit value is 2, this bit value is 4. All right, so this is how we represent num1. Okay, so here let me write num1. All right, and how we represent num2? Okay, num2, and we can represent num2 like this. Okay, all right, so question is saying that x should have the same number of set bits as num2. Okay, so number of set bits in my num2 is 2. Okay, so the new result that I want, okay, I want x now, so x should have same number of set bits, that is 2. Okay, now after that the value of x XOR with num1. Okay, so I'm doing x XOR with num1. Okay, x XOR with num1, and this value should be minimal. Okay, so how we can achieve that? Okay, so my what is my num1? My num1 is 0 1 and 1. Okay, so now I know one thing, that x should have only two set bits. Okay, so here I'm writing x, and here this is nothing but my num of 1. Okay, so I have to do what? XOR, okay, of these two. Okay, so here I know that x should have only two set bits. Okay, so first of all, XOR table, I hope that you guys already know, right? So if two bits are 0, okay, our output is going to be 0. If two bits are 1, our output is going to be 0 only. If any one bit is set, okay, 0 and 1, then it should be 1. Okay, here 1 0, then it should be 1. Okay, so here a b, and this is my result, which is nothing but a XOR b. Okay, so this is nothing but the truth table for XOR 1, right? Okay, so when two bits are same, then only we get output as 0. Okay, and I want the minimum value here, minimum. Okay, so to get the minimum value, if I set this to 1 and this to 1 and let it be 0 only. Okay, so here in my x you see only two bits are set, and now you see the output of this num1 XOR x. So 1 1, so here 1 1 0 1 1 0 0 0 0, so this value is minimum, right? Minimal value, right? If I am doing the num1 XOR x, this value is the minimal, and the number of set bits in x is also 2. Okay, so we get our result, right? This is the minimum value, right? So what is this? X 0 1 1 0 1 1, this bit value is 1, this bit value is 2, this bit value is 4. Okay, so output of this one is 2 plus 1 3. Okay, so here if you see, output is 3. Okay, so clear, very easy, right? So this is what we need to do here. The binary representations of num1 and num2 are 0 0 1 1 and 0 1 0 1 respectively. The integer 3 has the same number of set bits as num2, and the value of 3 XOR 3 is 0 is minimal. Okay, so I hope that you guys are clear. Okay, so now how we are going to solve this problem? Okay, so this is the next question. So same logic we are actually going to apply here. Okay, so first of all, what I'm going to do, we have to obtain our result, right? Final result. So in the final result, I will just add the value of num1 initially. Okay, I will say that this is my final result in the starting. Okay, and then we will just modify this num1. Okay, later on we will just modify this num1 later on. Okay, so first of all, how many set bit counts in target? Okay, this is what I'm going to calculate. So number of set bits in my num2 is 2. Okay, so this is what we are going to calculate, and then we are going to calculate the number of set bit counts in my result or num1. Okay, so in my result only I have added the value of num1. So number of set bits in num1 is equal to number of set bits in result, and which is nothing but num1 is 2 only. Okay, in the starting it is 2 only, right? Here also 2, here also 2. Okay, then we will check if the set bit counts. Okay, if the set bit counts here, okay, in my this one. Okay, if the set bit counts here in the result. Okay, so I'm saying that treat it as a result also in the starting. Okay, so if the set bit counts here, okay, if it is less than, okay, target set bit counts, so this is target set bit counts, then in that case what we need to do? Okay, so here if the set bit counts, okay, is less than the target set bit counts, then we have to check few more things. Okay, so here let's take one example now. So here in this example it's matching now, so let's take one example in which it is not matching. Okay, so here what we can do, uh, here you can say 0 1 0 1. Okay, so this is my result or num1 in the starting. Okay, result or num1 in the starting. Okay, so here 0, this bit value is 1. Okay, this bit value is 2, this bit value is 4, this bit value is 8. Okay, so number of set bits here in my result is just 2. Okay, and now the this is my num2. Okay, num2, and here let's say this is the case 1011. Okay, so here number of set bits is 3. Okay, so now I'm saying that if set bits, okay, is less than this target set bit counts, okay, then what we need to check. Okay, so initially I'm going to create one variable current bit. Okay, current bit. So here I'm just going to check in my result, and I'm going to set my current bit to 0 initially. Okay, so here 1010. Okay, 1010, and we need one more bit right in the result, because I want my result, okay, which is nothing but x, should have equal number of bits as in num2, right? So here it's just 2, we need 3. Okay, and now what we need to do? Okay, so first of all I'm going to check this bit. Okay, so if the current bit in the result is not set, okay, so it is 0 right now, then we have to set it to 1. Okay, because we need 3, we have to, so we need 3. Okay, so only in the starting position I can add now, because I want the minimal result. Okay, and this bit value is smaller, so only in the starting I have to add one extra bit. Okay, so here if it is not set, I'm going to set it 1011. Okay, I'm going to set it, and now will just increment the bit count to 3. Okay, number of set bit count to 3, and now both are same. Okay, we will stop. So this is going to be my final result. Okay, final value of x, or my result. Okay, whatever you want to say here, x result. Okay, so see here, now if I do the XOR of my num1, okay, in the starting num1 is 1010. Okay, 1010, and this is my x final. Okay, if I do the XOR here, 10 is nothing but 1 1 1 0 0 0. So this is the minimum value that we can achieve. Okay, this is the only minimum value. Okay, because we already know. Okay, so if my num1, okay, in the starting, if my num1 is like this 1010, and I'm saying that my x should have 3 bits, so definitely you guys know that 1 and 1 is 0, so definitely you guys are going to place 1 bit here, 1 bit here. Okay, and then you want minimum value, so instead of adding value 1 here, you are going to add one value here, right? so that you get the minimum value. Okay, so this is going to be your x. Okay, so this has minimum value, no? 1 2 4 8 if you do, so this has minimum value, right? 2 3 8 11, right? 11 is going to be the result, right? 11 is the minimum value, right? So that's what. Okay, so if you do the XOR, okay, of this x1 with this, so what will you get only one, only one. Okay, and this is minimal, right? Minimal, so you have to use 11 only here. Okay, so I hope that you guys are clear how we are adding extra bit. Okay, if the number of set bits is less than the target set bits, then we have to add the extra one in the least significant position, okay, at this particular position. Okay, and here we need to leave it as it is. Okay, 101, so here definitely we have to add 11 so that we can make both of 11 to 0. Okay, minimal. If I just use 0 here, then this value will be 1. It is very much larger than. Okay, then it's not the best answer, right? So to achieve the best result, I'm going to make it 1 here, make 1 here, and then another one which is left out, I'm going to set it to this position. Okay, and this is going to be the result. Okay, so this is one case. Okay, all right. And from here also there is one more thing that is clear, that if the set bit counts is equal to target set bit counts in the starting itself, then simply return num1. Okay, 0 1 1, and num2, here's 5 2 set bits only, so definitely I'm going to place under 1 1 only, so that I get 0 0 here. Okay, so it is best. Okay, if this is matching, just simply return num1. And if my set bit counts is less than my target set bit counts, okay, then in that case this is what we need to do. Here it is 1, here it is 1. Okay, in the result, so I have to add the additional one in the starting. Okay, if it is unset, okay, if it is not set, okay, 0, make it 1, and then if as soon as my count becomes equal, just stop it. That's it. Now there is one more case. There is one more case. If my set bit counts is greater than target set bit counts. Okay, so let's say this is my nums1 in the starting. Here nums1 in the starting, it's like this. Okay, and my nums2 in the starting is like this, 0 1 0 1. Okay, and this bit value is 1, this bit value is 2, this bit value is 4, this bit value is 8. So I am saying in the starting, let's treat this nums1 as a result. Okay, final result that we are going to obtain. So here, what is the total number of bit counts, set bit counts? Set bit counts is 3, set bit counts. Okay, and here what is the count of target set bit counts? 2, right? Target set bit counts. Okay, so now in this case, the set bit counts is greater than the target set bit count. Okay, so initially again, here create one variable, here we are getting the current number of bits. Okay, current bit. So here also initially our current bit count is 0 only. Okay, if we didn't execute this part, okay, in which set bit count is greater than target set bit count, okay, then we are going to execute this part in which my target set bit count is less than set bit count. Okay, so current bit is 0 initially. Okay, so now what we need to do, okay, so here I am just going to check this. Okay, so this is my final result. Okay, 1 1 0 1. Okay, I just need 2 bits. Okay, not 3. Okay, so now what I'm going to do here, so first of all here I'm going to check here if the current bit in the result is set. Okay, if it is set now. Okay, so here it is, I was checking if it is not set, so here I'm checking if it is set. So if it is set, okay, then I'm just going to unset it. Okay, so if I'm unsetting it, so I have to, it will become 1100. Okay, so now this 1100, if you add here in this, okay, if you do the XOR of 1100, 1101 and 1100, okay, so if you do the XOR of this one, you will get the minimum value, right? You will get the minimum value. Okay, so here in this case, if it is set bit, then just unset it. Okay, and now if I unset it, this count will become 2, and 2 is equal to 2, we have to stop. So 1100 is going to be the answer. Okay, is going to be my x. Okay, so here 1 2 4 8, it is going to be 12. Okay, So this is what we need to do, right? So in case of my set bit counts is less than target set bit counts, that is the first case, this case. So in that case, we have to check if the current bit is not set, then we have to set it to 1 and increment the set bit count. And in this case, we have to check if the current bit is set, then we have to unset it and decrement the set bit count. Okay, so this is what we need to do. Okay, so this is done. All right, so this is the main thing that we need to do, okay, in this problem. Now here, how you can set or unset. Okay, how you are going to set this particular bit or unset this particular, so that is very simple. Okay, so let's say you have a number like this. Okay, 1 2 4 8. Okay, so this is just additional information how you can set or unset a bit. Okay, so here let's suppose 1010. Okay, this is a number. Okay, this is a number. So now you want to check first, you want to check if this is bit is set or not. You want to check if this bit is set or not. So what you need to do, you have to take 1 and you have to left shift. You are checking which bit? You are checking this second bit. Okay, this is first, second, third bit, fourth bit. Okay, you are checking second bit, so you have to left shift 1 2 times. So how we write 1? We write 1 like this, 0 0 0 1. Okay, so we have to left shift 2 times. So one time, this is 0th bit. Okay, 1th bit. Okay, so we have to left shift 1 with just one time. Okay, not 2 here. 1 second, let me erase. One time. Okay, so this is a 0 position. Okay, 0 here. If 1 in the starting, okay, 0 shifts. If I am shifting 1 here, so the 1 shift. Okay, 2 shifts, 3 shifts. Okay, this is like, okay, so 0 1 2 3. Okay, so here if I want to check this bit, okay, so I have to left shift 1 one time. Okay, so here this is one, my initially this is my 1. Okay, I have to left shift one time. So here, what is the final result that I'm going to get? I'm going to get 0 0 1 0. I've shifted this one to this position. Okay, so we have to left shift 1 one time. Okay, if I'm checking this bit. Okay, first, second bit. Okay, so I have to left shift 1 time. Okay, all right. So after shifting it, I will just do what? I will just do AND operation among them. 1 0 1 0, and here we are getting 0 0 1 0 from here. Okay, this one, all right, and this one. Okay, so I will just do the AND operation among them. So what is the result I'm going to get? So here 1 1 0. Okay, uh, here it is 0, here it is 0, here it is 1, right? Here it should be 1 and operation. Okay, 1, and here 1 0 0. Okay, so here in this, if you see, we only set this bit in my AND operation. I take 1, I left it one time. Okay, so only this bit is set. So if this bit is 1, then only we will get 1 here. Okay, if this is 0 in the starting, okay, then we will get 0 only, right? So here, since this is 1, I am getting here 1. Okay, so here I will just check if my answer is not equal to 0. That simply means that this bit is set. Okay, this is a case on how to check if bit is set. Check if bit at a particular position is set. Okay, so we are checking the bit at this particular position. Okay, so what I did, I take 1, I left shift it with 1 time. Okay, and here if I want to check, I have to left shift 2 times. Here if I want to check, I have to left shift 0 time. Here if I want to check, I have to left shift 3 times. Okay, so since we are checking at this particular position, I have to left shift 1 time. So I did left shift, and then I just do the AND operation of the initial number and this number. Okay, so here, oh, here it is 0, it is 0, it is 0. Okay, so all these upper part will not matter in AND operation. Okay, so all will become 0. So if this is 0, then in the result we will get 0, but if this is 1, we will get 1. So if it is not equal to 0, that simply means that our bit is set. Okay, that's it. So this is a case on how to check if a particular bit is set. Okay, now next thing, how to check if given position in result is set. Okay, so here we have to check. Oh, no, this is already done. So now we have to check. Okay, let's suppose I have this x. Okay, so say 1010. Okay, 1010. All right. So now I am going to show you how we are going to set the given bit position in a result. Okay, so here I want to change it to 1, let's say. Okay, so this is just to check if bit at a particular position is set. Okay, now I am going to change it to 1. I want to change it to 1. Okay, so now how I'm going to do that? So 1, again take 1, and this bit position. Okay, so 1, here left shift it at 0 time. Okay, so this is 0 index, let's say 1 index, 2 index. Okay, so this is 20. Okay, so you 1, here 2 1, so this bit value is 2. Okay, this you guys already know, right? 2 bar 2, so this bit value is 4. This is 2 3, so this bit value is 8. Okay, so now here 0. Okay, so 1 left shift 0 times, so I will get this like this only. Okay, there is no change in position. Okay, now if I'm doing the AND. Okay, now if I'm doing the OR, sorry, if I'm doing the OR of these two. Okay, so 1010 10 and OR of this one 001. So what I will get, I will always going to set this bit. Okay, right? So this is my final here 1010. Okay, so here initially number was 1010. Okay, now what I'm getting 1011. So if you see here, this was 0. Okay, and this is 101 and this is changed to 1. Okay, so this is how we are going to set a particular bit. Take 1, left shift. Okay, the position. Okay, that many times, and just do the OR among them. Okay, OR operation. So this is for setting the bit. Okay, now how we unset the bit. Okay, so take same example. Okay, 1010. I want to unset this bit, let's say unset this bit. So what we need to do, take 1, left shift it with a 1 time. Okay, at this position we are checking 0 1 2 3. Okay, so 1 left shift 1, so initially 1 is like this, so left shift 1 time, so I will get my output as 0010. Okay, this is what I'm going to do. Now just do the negation of this one. Okay, negation, just change everything. Okay, so I will get 1101. Okay, I did the negation. Okay, 1101. So initially number is 1010, and now number is 10. Now negation I didn't, so my number is 1101. Okay, so this is nothing but 1101. Okay, just do the AND among them, AND operation. So what I will get, 111 10 is 0 1000. Okay, so see what I'm getting now, 1000. So here we just unset this bit. Okay, we change it to 0. See here. Okay, this bit we change it to 0. Okay, all other are same. Okay, so this is what we need to do for unsetting a bit. Okay, so these are the three things actually we are going to use in problem. Okay, first how to check if a current bit is set or not, then how to set a bit, and then how to unset a bit. Okay, and other things same story. Okay, same story we have to do. Okay, so now let's write the code. All right, so first of all we have to initialize the result to num1. Okay, we will modify result then later. Okay, so create one variable, int result is equal to num1. All right, and now calculate the target set bit counts. Okay, int target set bits count. All right, and here how we are going to get the count. So here simple formula, integer dot bit count. Okay, so this function is actually going to give us the number of set bit counts in num2 we have calculated. Okay, all right, so now we have to calculate the set bit counts as well. Okay, int set bits count is equal to integer dot bit count in the result. All right, okay, so now after that we have to start with the least significant bit. Okay, bit 0 in the starting. So int current bit, okay, take it 0. Okay, now we have to add bits to the result if it has fewer set bits than the target. Okay, first case. So here while set bits count, okay, if it is less than target set, then bits count. All right, so here if the current bit in the result is not set, then we have to set it to 0. Okay, so here if not set, so here I'm just going to call one function not set. Okay, so what we are going to pass, we are going to pass our result and the current bit position. Okay, current bit. So here let's suppose if it is not set. Okay, if it is not set, so is set. Okay, is set, and then I'm just doing the negation. Okay, so if it is not set, so then in that case we have to just update our result as, so here I'm just going to call one more function set bit. Okay, it is just going to set it. So in the set bit result I'm going to pass result and current bit. Okay, so I will write the code for this two functions later on. So but let's suppose that this set bit is just going to operate the result. Okay, and if I'm up setting some bit, okay, then we have to increment the count of set bits count to plus plus. Okay, because this while loop is running continuously, right? And then we have to move to the next bit. So for that purpose here we have to increment the current bit plus plus. Okay, this is done. So here this ends. Okay, this while loops. So now this is the case for add bits to the result if it has fewer set bits than the target. Now next case is going to be remove bits from the result if it has more set bits than the target. Okay, so just copy this and paste it here, and that's just, let's just modify. Okay, so if set bit count is greater than target set bit counts, then here I'm, instead of negation I have to check. Okay, now if the current bit in result is set, then we have to unset it to make it 0. Okay, so here instead of set bit, here I'm going to call one other method unset bit, and then we have to decrement the count of set bits. Okay, because here we are just unsetting. Okay, and then we are going to move to next position. Okay, and this is done, and here we have to just return result. Okay, that's it. So now this is done here. Okay, this ends here. All right, so now write the helper methods. Okay, three helper methods we have to write. What are the three helper methods? First one, helper function to check if the given bit position in a result is a set. Okay, so private boolean. Okay, so first of all is set. Okay, private boolean is set. Okay, so here we are passing one x and bit position. Okay, so here inside this what we need to do. Okay, so we are checking if it is set. Okay, so here if you see the code, check if a bit at a particular position is set. Okay, so what we were doing, we taking one and we are left shifting the one with the bit position. Okay, so here what I'm going to write, I'm going to write one left shift with bit. Okay, this is what I'm doing, right? And then after shifting I'm doing the AND operation. Okay, AND operation with what, with the actual number. Okay, so here I can write like this, x and, okay, this one, this is the thing that I'm doing, right? So here if the result is not equal to 0, okay, okay, so if the result is not equal to 0, then definitely that means that it is set. Okay, so if the result is not equal to 0, okay, if it is not equal to 0, so definitely that means that it is set. Okay, so return this. If it is not equal to 0, then it is going to return true. Return true means that it is set. Okay, that's it. This is the code for that one. That's it. Now next is how to set the bit. Okay, so here private int set bit. Okay, same thing here, int x and int bit. All right, so here what we are doing, so here if I move to the next position, okay, so here what we were doing, um, we are setting the bit. Okay, it was 0 initially, we are setting it. Okay, so how we are setting it 1, and then I'm doing the left shift of 1. Okay, and I'm doing the OR operation, okay, with this actual value. Okay, so here can I simply write return, just copy this, return here x, and then I'm doing OR, okay, with 1 left shift bit. That's it. Okay, that's it. So this is for setting a bit. Okay, now unsetting a bit. So here write the code for that one. This is going to be the last step for this problem. Int unset bit, same way pass x, pass bit. All right, and here what we have to do, so here if you see 1 left shift, okay, position, and then I was doing the negation, and then I was adding the negation to the end with the actual result. Okay, so here return, copy this, paste it here, instead of or what we were doing and, okay, and here it was nothing but the negation of this one. Okay, that's it. So that's it. Okay, so now let's run the code and see if the encode should try to fix that. So the test case has been accepted. Wonderful. Now let's submit it. So see, our solution is accepted, right? So I hope that you guys are able to understand today's problem, and if you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you guys in the next video. Thank you. Bye bye.